Good day. Now we'll discuss the second discrete probability distribution, which is the Poisson probability distribution and application to its word problems. So the Poisson probability distribution, or PPD, is another important probability distribution. It is applied to experiment with random and independent occurrences. The occurrences or success are random, which does not follow any pattern, and it is unpredictable. The independence of occurrences or success means that the event does not influence the successive occurrences or non-occurrences of an event. The occurrences are always measured with respect to interval such as time, space, or volume. So the actual number of occurrences within an interval is random and independent. So this is our formula. X is from 0 up to we do not know. Okay, so n is not given. So unlike in the discrete, what do you call this one? The other one, the binomial, it has an upper bound n. Here, n is not always given. So the mu is the mean number of occurrences in a particular interval or time. Take note of this, in a particular interval of time. E, of course, it's approximately 2.71828. And X is the number of occurrences. So this usually appears on the question. So let's apply this. A vintage car breaks down an average of 4 times per month. So meaning the time interval here is per month. That in a month, this vintage car breaks down an average of 4 times. So using the PPD formula, find the probability that during the next month, because our interval here is month, so we have this. The next month, find the probability that this vintage car will have A, exactly 3 breakdown, B, at most 2 breakdowns, and C, more than 1 breakdown. So for letter A, exactly 3 breakdown. Take note, our mu, the average is 4. 4 times per month. So our X is 3 because it's exactly 3. So using the formula, review, our formula is what? Mu, the mean, to the x, e to the negative mu over x factorial. Okay, so our mu here is 4. So 4, our x is 3. 4 to the 3, e to the negative 4, divided by 3 factorial. So using your calculator, the answer is 0.1954. Okay, letter B, at most 2. So at most 2, we have this. So it means that we will compute for P0, P1, and P2. So using the formula again, so just substitute. We'll have these values, and then we have 0.2391. Now you may pause the video if you want to try to compute these expressions in order for you to practice using your calculator. Again, last is more than one breakdown. So more than one means 2, 3, 4, and so on. But we have no n. Now we do not know where to stop. So in short, we will use complementation. Okay, now in this type of problem, if our mathematical symbol or inequality is greater than or equal, we will use complementation. Okay? Why? Because we do not know when to stop. Wala tayo n. We have no n. So use complementation. So we have this. So x greater than 1, if I illustrate this one in this manner, x greater than 1, so we'll start with 2, 3, 4, and so on. Here we only have 0 and 1. So we will subtract 0 and 1, this probability, from 1. So that is complementation. Okay? So using the formula, we have this, substitute, and then use your calculator. You will have 0.9084. Example 2. Consider the case where the predetermined average number of bus arrivals at Cubao Station is 6 per 15-minute period. So this is our interval. Okay, 15-minute period. So our basis for our data is the 15-minute period. So according to this, an average of 6 buses will arrive per 15-minute period. Find the probability of exactly 4 at least 4 buses arriving in a 15-minute period. So the mean is 6, which is given. Now for letter A, exactly 4. So again, use the formula. Substitute them on your calculator or input them in on your calculator. So we have 1339. At least 4, meaning 4, 5, 6, and so on. Again, so this is greater than or equal. Since this is greater than or equal, we will use complementation. Okay? So, if we illustrate this one, so we have 4, 5, 6, and so on. We do not know where to stop. So, therefore, we will delete this because this is not needed. This is 0, 1, 2, and 3. So, that's why we have this complementation. So using your calculator and formulas, you will arrive to 0.8488. Example 3. The average number of motorcycle accidents in C5 road is 3 per week. So this is our interval per week. Assume that the number of accidents follow a Poisson distribution with the mean 3. Find the probability of at most 2 accidents. So at most 2, so we have this less than or equal to 2. So we can compute P0, P1, and P2. And we're given with the mean equal to 3. So again, substituting these values to the given formula. So we'll arrive to 0.4232. A physics teacher has observed that the number of errors in new modules varies considerably from module to module. After some analysis, she concludes that the number of errors in a Poisson distributed with a mean of 1.7 per 25 pages. So this is our interval per 25 pages. Now take note, the mean here is in decimal, no 1.7. So it does not mean that when we talk about mean, it's always a whole number. So take note, mean is average. So it is a continuous number. Continuous variable, so it can take a decimal number. So the teacher randomly selects 25 pages of the new module. What is the probability that there are exactly 2 typos? And the other one, 2 or fewer typos. When we say 2 or fewer, that is at most 2. So the mean is 1.7, which is given. Let's answer first the first one. Exactly 2. So using the formula, we'll have 0.2640. So at most 2, again, we'll have P0 plus P1 plus P2. Then substitute and use your calculator. We'll have this. So it's very high. Of course, we're just humans, no? Unless maybe a computer or an AI will encode, maybe the errors will be minimal. Example 5, at a Major League Baseball park, 5 customers arrive at a concession stand on average in a 10-minute period. So that is our interval. What is the probability that in a 10-minute period, A, exactly 4, B, fewer than 3 people will arrive at the concession stand? So it's given that the average that will arrive, number of 5 number, the average number of customers arriving in a on the or in a major baseball league park in a 10-minute period is 5. So compute, use the formula. Now, fewer than 3. So fewer than 3. So 3 is not included. So it means at least 2 or at most 2 I mean. Okay? So again, use the formula and your calculator, you will arrive to 0.1246. Okay, example 6. Hits on a new business website occur quite infrequently. They occur randomly and independently with an average of 6 per week. So this is a Poisson, so we have an interval of per week. Find the probability that the site gets A, exactly 4 hits, B, at most 1 hit, and C, at least 2 hits per week. So the mean is 6, which is given, average 6 per week. So let's answer first letter A, Px equals 4, so we have 0.1339. Okay, you may again practice with your calculator. At most 1, so we only have 0 and 1. So using your calculator, we have this 0.0174. And last, at least 2. So we will use complementation because it's very long and we do not know where to stop. So by complementation, we will subtract the less than 2. Right? So less than 2 meaning it starts with 1. 1 and 0, pababa. So, okay, we have this. So using your calculator, we have that. Or formula and then your calculator. And then we have 0.9826. So there is a big chance, big probability that at least 2 hits per week hits the new business website. Next, example 7. According to the National Office of Vital Statistics of U.S. Department of Health and Human Services, the average number of accidental drownings per year in the U.S. is 3 per 100,000 population. Now, find the probability that in a city of population 100,000, there will be A, no drownings, B, at most 3 drownings, and C, at least 3 drownings in a year. So it's given that the mean is 3 here. No drownings meaning 0. X equals 0. Okay, so using the formula, we have 0.0498. So there is a small chance that there will be no drowning in that year or in a year. At most 3, so we have P0, P1, P2, and P3. Use the formula. Using your calculator, we have these. So we have 0.6472. Okay, so there's a big chance of having these numbers of drownings in a year, at most 3. And last, at least 3. At least, so that is greater than or equal. So we will use complementation, okay, because we do not know where to stop. So what is the opposite of this? The complement is less than 3. Okay, so it's only 0, 1, and 2. So we will subtract 0. This is minus, this is minus. Okay, so minus. Then using your calculator, we'll arrive with 0.5768. So both B and C have a high chance, no? Big probability. So there is really a drowning per year. Okay, last example. Each week, Stephen needs to prepare 4 exercises for the following week's homework assignment. The number of problems he creates in a week follows a Poisson distribution with mean 6. What is the probability that he manages to create A, 5 exercises, B, at most 3 exercises, and C, enough exercises for the homework? So the given mean is 6. So let's start first with A. So exactly 5 exercises. So we have this formula and this substitution. So the answer is 0.1606. So a somewhat small probability that he will make exactly 5 exercises. Next, at most 3. So we have P0, P1, P2, P3. Substitute them on the formula. Use your calculator, and the answer is 0.1512. Okay, so there is a small chance again that Stephen will create at most 3 exercises. Now, what if we have enough exercises? So, enough, no, other students will say that it's equal. Now, it can be equal, of course, but it's also accepted that if you provide more than what is expected or what is needed. So that is greater than or equal. So enough is greater than or equal to 4. So since this is greater than or equal, we do not know where to stop. So we will use the complementation. So the complement for this is less than 4. So we will subtract 0, 1, 2, and 3. Okay? So using your calculator and formula, so we have 8488.